Good afternoon and welcome to our presentation. My name is Marc Henley. I'm here with my colleagues Darren Dunn and Hamilton G. We're here to present to you our findings on the past, present, and future of solar energy utilizing the IBM Watson Analytics platform. So first off, the reason we chose solar energy, specifically solar PV or photovoltaic, is because of the increasing trends towards environmental concerns and increasing CO2 pollution. And so what we wanted to look at is we looked at in the United States, the current capacity for solar voltaics is about 16,500 megawatts at an average cost of about $633 per watt. And there's nearly a million solar panels installed in the U.S. So a few of the questions that we wanted to answer while conducting this analysis was we wanted to look at what is the general sentiment towards solar energy, which factors will help the development of solar photovoltaics in the United States, what are the implications for relevant stakeholders, and how could the tools generated from this analysis help them. The data sets that we used, the primary data set that we used in this analysis was the Open PV project. The Open PV project is a community-driven comprehensive database of solar photovoltaic installs in the United States. It provides it for the whole country as well as state-by-state data. It provides location, the size of the project, the overall cost, any government incentives, the install type, and who the installer was. We also looked at used the Bloomberg terminal to collect daily settlement data for West Texas intermediate crude oil price from 2010 to 2015. We also utilized U.S. government census data, specifically U.S. Energy Information Administration data and electricity generation emission, as well as supplemental data such as state population density and the number of housing units in each state.
So when we begun this analysis, we really weren't sure where to start. We knew that we wanted to evaluate solar energy and the general talk around that, but we weren't sure what country was leading the charge. So to answer this question, we relied on Watson's social media analytics. By analyzing the topic of solar energy, we were presented with this geographic map of what countries are mentioning it the most and what countries are talking about it the most. And as you can see, by the US with its deepest color blue actually makes up the largest share of voice surrounding this topic. So as such, we wanted to gear our study to the US. In digging deeper within the social media analytics, we also analyzed the general sentiment towards solar energy. And as you can see, it's overwhelmingly positive with a positivity score of about 55%. And we also see a large chunk of neutral talk. And just for information's sake, we wanted to see if there were any trends from the past until now. So we reached back as far as we could to 2015. As you can see, the positive talk was actually somewhat greater when compared to 2017. And if we flip back to 2017, we see that the neutral chunk has actually grown. So this led us to believe that as time moves forward, the conversation of solar energy is sort of becoming part of the day-to-day talk, which means that the conversation will be more neutral. So moving on, we also wanted to evaluate some large macro trends occurring with PV technology and solar energy within the States. So here we have two graphs. On the left, we see that residential and commercial PV pricing over year is declining over time. And when we compare this to cumulative PV power over year, we see a sharp incline. So this leads us to believe that as the price of the technology is decreasing, its use is rapidly increasing. Next, we actually wanted to evaluate if the use of PV technology is doing its ultimate job, which is reducing CO2 emissions from energy production. So again, on the left here, you see that the CO2 emissions from energy production are declining year over year, and comparing that to cumulative PV power, we do again see that spike. So we knew that we had just sort of hit the tip of the iceberg in terms of insights regarding the US and solar energy. So we wanted to build a dashboard that presented the user with a number of insights. So flipping over here, you see the dashboard that we've constructed, which focuses solely on the United States. This top bar graph just shows a quick breakdown of population demographics, specifically the sum of urban population compared to the sum of rural populations. And again, you'll see a couple other widgets here that summarize the count of total PV projects in the States, the average cost per watt from solar energy, and the total capacity generated from PV technology. But what's unique about this tool is we can actually drill down into each state to get even more insights. So by clicking on California, we can see that the count of PV projects is over 600,000, and they're generating over 7,000 megawatts. And again, we can quickly click on another state to compare. Here, we'll click on New York, and as you can see, the average cost per watt here is actually cheaper when compared to California. And one important thing to note is these black dots do represent the total capacity generated from PV technology. And as you can see, California here is a dominant player, as well as New Jersey.
So the second dashboard is time series based and provides additional insights to relevant stakeholders. So by clicking the play button here, the dashboard will display how has the cost per watt changing by years. So a major takeaway from this dashboard is that as the cost per watt by year has been decreasing continuously, the residential solar PV installations has been increasing significantly over the 5 years, and by clicking on different install type on the dashboard, you could actually see the breakdown of how has the trend based on different install type has been changing over the 5 years. And moving on to the predictive model, we have several insights. The first one being the factors that affect cost per watt of solar PV. So through we find that two major drivers to a lower cost per watt in California are the number of residential installations in California and the number of times that incentive programs by Los Angeles Department of Water and Power has been involved. And we in our predictive model, we specifically looked at two pioneering states in terms of solar PV development, which are California and New Jersey, who are the biggest two states in terms of solar PV capacity. And the next insight is we looked at the factors that affect the number of residential users of solar PV. So we think except for the incentive programs provided by the local government, there's also an important role from the business side to promote the installation of PV and to promote a more cleaner energy environment. And so in this predictive analytics, we find that one of the biggest solar PV installer, which is SunPower, is actually a strong predictive factor in terms of the total number of residential solar PV installations in California. So the last insight is about what is the implication of from an environmental protection perspective. So in this case, we looked at New Jersey in particular because nearly 23% of electricity in the state is generated by solar. So from this predictive model, we actually find that the total capacity of solar PV and the number of residential installations in the state are both negatively correlated with the amount of NOx generated from electricity generation. And in our predictive model, we also included the data from Bloomberg terminal. However, there doesn't seem to have a statistically significant correlation between the traditional energy sources and the development of solar PV.
So in conclusion, what we've shown is that the increase in solar installations has actually had a positive effect on carbon emissions. The CO2 has actually been decreasing on a relative downtrend. There's also been increasing residential solar panel installations, as well as reduced costs with regards to average costs and install costs. And that incentives are actually a major predictor of residential installations. So based off this, our recommendation is that governments provide more incentives specifically targeted towards residential customers in order to increase adoption and reduce costs overall moving forward. Thank you.